All right, welcome to the last talk of the morning session of day 3 of the UGM 2020 for iRODS. This is going to be Jonathon Anderson from CU Boulder and Kory Draughn from the iRODS Consortium talking about the work that went into the logical quotas policy plugin. Go for Jonathon.
Great, thanks, Terrell. Yeah, so my name is Jonathon Anderson, and I'm going to talk today about our ongoing deployment of iRODS as part of our PETA Library Research Data Storage Service. This is at University of Colorado Boulder's Research Computing Group. And then, like Terrell said, at the end, we'll hear from Kory also. Kory has been doing, Kory is a research software developer at RENC, and he's been the primary developer for lots of things, including this new iRODS logical quota policy plugin that is kind of the primary feature we're discussing here today. So real quick, Research Computing is a central services group within our greater Office of Information Technology. We're what you would think of as a kind of a traditional HPC shop. We have a couple clusters, including an NSF machine and then a Conda machine that we operate from contributions from independent research groups. We operate a storage service that we call the PETA Library, which we'll be talking about mostly today. And then we co-manage a dedicated science network plane that spans most of the Boulder multi-campus area that all of our equipment is on, and then other groups on campus can buy into it as well. The PETA Library has been in operation for about 8 years. Starting with the tape library that you see here on the left. It's accessed as tiered storage. So we have GPFS and TSM, HSM thing. So people have done file IO directly to the GPFS, and then things that land there are automatically pre-migrated to tape. And then we treat that local disk, the GPFS file system, as a cache and stub things out, which happens very quickly at that point when the disk space is needed for other ingests or recalls. And as the PETA Library service has expanded, this part of it has come to be called the PETA Library Archive. We sell access to both this archive and a separate active storage system at a $1 or $1 per terabyte per year rate. In the original environment, we created a GPFS file set for each allocation and then set quota limits on that file set. So users paid upfront for a year of storage and then could only store as much in as they had bought. And then end users tend to access their data over NFS, either on the login nodes. The archive is only mounted on login nodes, and then our data transfer nodes. Other file systems are mounted more widely. And then the data transfer nodes re-export that over Globus for larger data transfers with other institutions and sometimes within the CU ecosystem. On the right is the new environment, which is a SpectraLogic tape library with a Strongbox appliance that is meant to replace this. But the Strongbox does not provide a facility to configure quotas on or within the shares that it defines. At most, we could create like a share in the Strongbox per allocation and then limit the number of tapes that can go into it. But the tapes are 9 terabytes, and we want to be able to allocate space at a finer grain than that. Plus, that kind of physical allocation isn't quite what we've done with this before. So we wanted to be able to set allocations like what we were doing with GPFS file sets elsewhere. And this has been a problem for a while, actually. So even in the legacy environment, GPFS's quotas don't actually manage the space in the tape library. It only manages the quotas on the disk. So as soon as things were migrated off to tape, they came off of your quota. So we had a whole bunch of messy scripts in the back that tracked how much data you had in TSM, and then prevented migrations to tape when you had exceeded your tape quota. So it's always been a mess, and we were hoping that this whole infrastructure would clean it up. Due to some other mishaps, a product that was meant to do that didn't. So we turned to iRODS and thought perhaps we could do something with the policy engine there. So here's what we have in iRODS now in that new archive environment. Our Strongbox exposes a set of NFS shares that are configured in iRODS as storage resources. those resources are then aggregated as children of a single parent random resource. And we do this because Strongbox will only ever do IO with a single tape drive at a time for each share. So by having multiple shares, we allow iRODS to use all 4 of our tape drives simultaneously. If we added additional tape drives, we would add additional shares to continue to parallelize that. We primarily use NFS rods right now as the client into our iRODS environment to try and mirror as close as possible what people were seeing before with NFS mounts on login nodes, and then also to make iRODS accessible to Globus. And if you were attending yesterday, you will know that Kory also did the vast majority, if not all of the work on NFS rods as well. So we're very appreciative to him for that also. So the next part, again, what we're really here to talk about today are these logical quotas. iRODS already had user and group-based quotas built in. And again, I think it was Tuesday, someone was talking about a little bit of like the per resource quota stuff that they were doing. But we wanted to be able to set a maximum size, not per user or group anywhere in the zone, but on a directory or collection. So again, similar to how GPFS file set quotas work, or if you've used ZFS, there's a similar function as file system quotas. And again, iRODS didn't have that built in, but in a phone call standing in a loud part of our data center one day where I was talking with, I think Kory may have been there, but also Terrell and Jason, I was like, what if we use the policy engine to do that? And if you've, I presume everyone here has talked with Jason at some time or another, the answer was, of course, iRODS can do that. Of course it can do that. So we just kind of jumped in with both feet and assumed that it would all work out. But I'll leave it to Kory to talk about exactly how it works. But in preparing for this, I set up, and my test iRODS environment that I usually use had fallen over for completely unrelated reasons, and it took me all of like an hour to set up a new one with all of this turned on. So all of this is available as RPMs, and I presume debs. Kory, I forgot to ask you if debs are available also, but I don't have a Debian distro right now. Do you happen to know if it's being packaged for?
Yes, debs are available.
Cool, thank you. But yeah, you just throw this rule engine into your server config, and away you go. And it's compatible with iRODS 4.2.8. There were development versions that we were using against earlier versions of iRODS, but I think the first actual release is compatible with 4.2.8. So you can interact with this plugin with iRule directly, which is how the docs are written on GitHub. But we wrote a tiny little script that I call iLogicQ that does it for us. It's mostly just shelling out to make things a little bit more approachable for me. This isn't merged, but I have a fork that you can see in the link down here where I've contributed it, a work in progress version of it there. It needs some more like help text and things like that, but I'm hoping to get that cleaned up and at least get a pull request submitted. We'll see if it actually makes it upstream. So for example, in here, this is on that new test environment that I mentioned. I created a new collection called File Limited that we're going to place a file, like a number of files quota limit on. And then I put some files in it, or sorry, I start monitoring it, which tells the logical quota system to start tracking the number of files and the amount of data in it. I create a file in it, or actually I put 5 files in it, make an empty one and put it in there 5 times. And we can see that these 2 APUs that logical quotas is using to track that data is updated. See, total number of data objects gets updated to 5. Total size in bytes remains 0 because they're empty files. But then over here on the right, we set, let me move some windows around here. We set a maximum for the number of objects on that collection to 9. And then if I try and put 5 more objects in, the last one returns an error of an invalid input parameter because of a quota violation. And we can look at those values again, see that the maximum is being tracked as 9 because that's what we set it to. And the total is 9. And then if we look in that collection, we can see that those 9 files were added and the 10th one was prevented. And the reason we care about file limits is because we're doing this on a tape archive. And so our experience, at least in the past with TSM, was that it doesn't behave well with lots and lots of files. So we tend to give out quota in this environment specifically with a defined ratio of space to number of files to try and encourage a certain average file size across an allocation. But the more interesting thing for most people is probably a size limit. So here's another directory where we define a size limit and we start monitoring it and set the max size to 35 megabytes here. Logical Quotas is tracking bytes underneath, but this iLogicQ script is interpreting different potential suffixes and translating that for me. Create a random file and put it in. It's about 10 megabytes. And if I put in, too many copies of it, we get the same kind of error back, that we are exceeding a quota limit. And if we look, we see that we can fit about 3 of these in there because I set a limit of 35, and that last one was prevented. So in general, our real world experience with this has been fine, or not even in general. I have experienced no problems with the latest release in real world use, especially with the kinds of the kinds of use that we consider typical of our archive installation. So where people are mostly just putting files in kind of a linear fashion or one at a time. But Kory had mentioned concern at a lack of locking and how this is implemented. And he may talk more about the details of that in a little bit. But that we might experience drift in certain use cases. So I created a terrible little script that you can see, you can access using the gist at the bottom there if you're interested, but it's real dumb. It just uses an input random file and puts it into a random sub collection of a collection, and then randomly deletes an existing file out of that collection as well. And does that a bunch of times, and then I ran several of them in parallel. And in doing that, so if you think about how this is working, each time you do IO to a tracked collection, it's updating a shared value, right? And there's a race between the calculated change that it wants to make to that value and the updating of it. So we did see drift in those values, equivalent to 1 or 2 misses of where 2 things decided to update the value at the same time, and one of them won and missed the other update. For our use cases, like there's a function, one of the things that iRule can do here, or one of the things that Logical Quotas can do is just rescan and update that value. And for our purposes, that's probably fine. But I've also been talking with Kory to see if it might be possible to add locking to this. But again, I am not the one doing the programming for it, so I can't speak to it too authoritatively. It's just wouldn't it be nice if we could figure out a way to make this just correct over time, but we'll see. So with that, I think we'll turn over to Kory for the next few.
All right, thanks, Jonathan. So yeah, I'm going to just talk about some of the design and implementation details, surrounding logical quotas. So when we started this project, we initially implemented the first version of it using the native rule language, and we did that because it was a proper space to do any like prototyping that we wanted to do. We could verify design decisions and basically formulate something that would work long term. And what we came up with was we used the prepeps to compute deltas and detect violations. So let's say you're trying to write bytes, you're trying to write something to a data object, to a replica. And as these bytes are flowing through the system, the prepeps are computing like what's the change, like whether are we shrinking the file or are we increasing the size of the file. And we take those deltas, and then we take the current tracked values, and then we try to verify whether any violations were anything was violated. And so with that, then we can, if there aren't any violations, then we can use the post PEPs to simply perform updates. And this turned out to be really, really good. And this proved to be, this was proof to us that we could actually do this in iRODS, but doing it in the native rule language had some limitations. For one, there's no real libraries other than the microservices. We can always write microservices, but that takes time, and we don't want to write things that are specific to things like logical quotas per se. So what we decided to go with was we would re-implement this using a rule engine plugin, using C++. And this has a lot of benefits in that, first of all, because we're using C++, we're really close to the hardware, and C++ exposes us to the ability to write more optimized code that can run better. It also allows us to basically encapsulate things better, and basically gives us a wealth of tools to design things in a way that makes it easier to implement as well as maintain. So next slide. So this is a very, very scaled down version of some of the code you would find in a rule engine plugin, such as logical quotas. This actually is looking to be, as far as when I write any of these rule engine plugins, this is a typical scheme that I follow, depending on what it is I have to accomplish. But if we look at this example, we use basically, we have a class called PEP API data object copy. And this is essentially, this acts as a namespace for the pre and post PEP, as well as a space for sharing information between the PEPs. So, and what this enables is that we don't have to come up with any special ways of sharing information between the PEPs. Essentially, it's just we just have some static functions that live inside of a namespace, and we can basically share the information. We can avoid doing things like recomputing values that we've already computed in the pre-PEP. We can just simply store them and then just apply them in the post-PEP. And this is really nice for maintenance and being able to upgrade, and for even newcomers to come in and look at the code and understand what's happening. Instead of you having just a bunch of free functions like you might find in a C application, we have the ability to only think about just that particular operation that we want to handle. From there, we also, if you look at the bottoms from line 16 and 19, the rule engine plugins typically have like a map of handlers that represent the PEP name from the actual handler that will be invoked. And if you look, and if you see here, we just basically have a table of strings to the pre and post PEP. And as rules are fired, we can just do a simple lookup, which gives us, of course, order of one lookup time to instantly execute that handler. So next slide. So now I just want to talk about another thing that we had to consider, and that was performance and correctness. And with this plugin, we decided to go with performance, and that's for basically a number of reasons. Just to go through some of the pros and cons of each. If we look at correctness, the pro is that the numbers that are reported back out to you are correct always, right? But this has some issues in that to do this, that means we need zone-wide synchronization, right? It also means if we introduce synchronization that we have to, this decreases responsiveness when we're dealing with collections that are being monitored and they are also nested. So just to let you know, like the logical quotas engine also supports nesting with monitored types. And anytime you make a change to something that's deeply nested, we have to propagate all those changes back up to the parent. And so moving on to performance, with performance, we don't need synchronization at all. We just let things happen and we can respond to those. And this stays responsive because we don't have synchronization. But to get around, but the issue with this is that the numbers that are reported, as Jonathan mentioned earlier, they can drift. And to solve that case, what we do is we just provide helper rules to basically allow you to recalculate things. And basically this allows you to do things like schedule. Maybe you can use the delay server or the delay server, as well as this rule to schedule like maybe daily updates or maybe hourly updates. And this is really nice because the delay server actually really is fast now and doesn't get hung up on things like this. So next slide. So just some interesting things that we encountered during the development of this rule engine plugin is that before 428, opening a data object with the truncation flag was not reflected in the catalog immediately. This has been fixed in 428, so anytime you do open up a replica, the file on disk is, we know that that's truncated, but the actual catalog will also reflect that immediately following the open. But this was a problem during the development of this because some operations with logical quotas requires that the size be known to carry out its operation. And for this, again, dstream came to the rescue because we could do some tricks with dstream, like open up that data object and just seek to the end and ask the dstream object exactly where we are. And that was a way we could get around this during development. Another great thing with this rule engine plugin was that it gave us iStream. There was a way that we really needed a way to test this, all of the capabilities in this. And so that led to the development of iStream. And I'm kind of running out of time, so I'm just going to kind of jump through this last one. I guess another thing that was really nice is the metadata guard, which you can read about. That's another rule engine plugin that allows you to basically instruct to protect metadata. Well, basically you can mark certain metadata as administrative, and therefore basically disallowing any normal users to change that. And I think that's it for me. So I'm going to pass it back to Jonathan.
Yeah, so at this point, we're mostly just, we can take any questions, but if you are interested in the rule engine plugin, or in the logical quotas rule engine plugin, it's up on GitHub, as with most things, at the link up there. And presumably everyone here knows where iRODS.org is, but if you want to know more about research computing, there's a link there, and then a couple email addresses that you can contact for more information or help in general. But yeah, that's what we have, other than questions that you might have for us.
Very, very good. It's great. Thank you so much. I think we've got one question that may have already been answered. Is there any reason to use the native rule language implementation at this point?
Well, you can certainly use it. It's actually not complete because while we were able to prove to ourselves that we could do this, there was just more benefit to rewrite it in C++. So, I mean, if there's interest in doing and completing this using native rule language, then we can do that. But right now, it's just, you can look at it as a prototype.
Right.
Yeah, for our purposes, like the first thing that we ran into, even without knowing any of the backend reasons to go to the C++ implementation, was that it just didn't support quotas large enough. Like when you're expressing the values in bytes, at least the default integer that was being used in that implementation was far too small for us to do anything reasonable with it. I don't know if there's bigger data types or not. But.
And then the second part of that question was, well, I think you answered this. What was the effort required to migrate from that to C++? But it sounds like with a little bit of a framework now and some practice, it's not that much work.
Right.
Let's see. I don't think we have any other questions. Anybody want to raise their hand and ask anything? Otherwise, we might be good. What would you say is the biggest surprise in going through this exercise from either of your perspectives?
You want to go first?
Yeah, mine is non-technical. We're still relatively new to the community and the consortium. And my biggest surprise was just how easy it was to work with you guys to develop something brand new, and how acceptable and expected that was. That if we had a use case that actually seemed like anyone might care about it, that it just happened. And we provided experience and feedback on it but mostly, yeah, code just magically appeared, and I don't know how that happened, you know.
Who knows?
Yeah.
Could be anything.
I think the biggest surprise for me was just how much the native rule language could actually do, because this was the first time I had to really, really write something using that. And it really pushed me. And also I learned a lot of things with the help of Dan and the team about the native rule language, but it's a fully capable language of doing a lot of these things. It's just whether it meets your requirements, right?
That's
Yeah,
right.
that's true. I had not done anything like this with iRODS before, and even like Kory immediately had surpassed anything that I had done. But even before we got a release from Kory, I had basic tracking working in the native rule engine language. It was just all of this is very easily approachable and pluggable, and I should dig into the C++ stuff because I bet that would make it seem even more flexible for us.
Do it.
We have one question from Mauro at the EMCC. He says the logical quotas can be used together with the standards iRODS user quota microservice implementation, or should those not necessarily mix together?
I think they just wouldn't do anything intelligent, right? They would each have their own limits in their own circumstances.
Right. Yeah, it sounds like this was created because we cared about it at the logical level, and the earlier way was counting bytes on disk because it's a disk, right? Because it's a user that owns it.
Yeah.
Very good. Well, we are on time. Thank you both, and we will see you soon, Mr. Jonathon Anderson.
All right.